Imagine you wake up one morning and before you even get out of bed, there is this just crushing heavy fog sitting right behind your eyes.
Yeah, that awful, almost physical mental weight.
Exactly. Your thoughts feel like they're, moving through molasses. Your knuckles are stiff and your knees ache literally the second your feet hit the floor.
And your immediate thought is probably that you're coming down with the flu or something.
Right. Or maybe you just pushed it way too hard at the gym, or, you're just severely sleep deprived.
But what if the actual culprit behind that full-body inflammatory response wasn't a virus at all?
Yeah. What if the culprit was the structural protein holding together the bagel you ate for breakfast 2 days ago?
It's wild to think about, but it completely upends how we traditionally view food and biology.
It really does. And welcome to today's deep dive. I'm so glad you could join us for this one because it's a topic that affects so many people.
Absolutely. It's great to be here.
We are conditioned to think of the digestive system as this completely isolated mechanical tube, right?
Right. Like you put food in, the engine burns it for fuel, and that's just it.
And if a food disagrees with you, you expect a localized reaction. Heartburn, bloating, and upset stomach.
But the reality, the actual biological reality, is that the gut is the command center for the entire body's immune system.
A localized event in the intestine can trigger a systemic, body-wide alarm, an alarm that crosses the blood-brain barrier and inflames your joints.
Which brings us to the mission of our deep dive today.
Yes, we are unpacking the incredibly complex, often really murky relationship between what happens in our gut and how we experience systemic inflammation.
Specifically through the lens of autoimmune conditions.
To do this, we're relying on a really fascinating source text titled About Gluten.
It's a great document because it combines hard biological science, the actual mechanics of human digestion, and this deeply compelling first-hand patient account.
Yeah, an account from someone living with rheumatoid arthritis, or RA, who has meticulously tracked their dietary responses.
Our goal here is to basically bridge the gap between microscopic biochemistry and the microscopic reality of chronic pain for a patient.
Right. Okay, let's unpack this. We have to move past the, oversimplified diet culture buzzwords.
We really do. We need to look at the actual physics of the proteins we consume.
So let's start at the very foundation. The bagel, or the pasta, or the soy sauce. We need to talk about gluten.
And honestly, we need to strip away all the grocery store marketing.
Because the word gluten has kind of lost all meaning, hasn't it?
Totally. It just looks like a green check mark on a box of crackers to most people now.
But if we look at the raw botany and chemistry, gluten is just a natural protein network found primarily in wheat, barley, and rye.
And fun fact, the word itself comes from the Latin word for glue.
Which is honestly the perfect way to understand its function.
Yeah, if you isolate gluten in a laboratory setting, specifically the two main proteins that make it up.
That's gliadin and glutenin, right?
Exactly. If you isolate gliadin and glutenin and you hydrate them, you don't get a powder or a thin liquid.
You get this incredibly sticky, stretchy, cohesive mass.
In the natural world, it's just there to nourish a sprouting plant.
But in the culinary world, it is the ultimate architectural scaffolding.
It really is. I mean, how do you usually visualize it when you're explaining it?
I always think about it like pouring a concrete foundation.
Oh, that's a good analogy.
Right. If you just pour the concrete, which in baking would be your starch and water, it might dry hard. But the moment you put any pressure on it, it crumbles.
It has no tensile strength.
Exactly.
Yeah.
So construction workers lay down a grid of steel rebar before they pour. Gluten is basically the culinary rebar.
That's spot on. When you knead dough, you are physically aligning these gliadin and glutenin proteins into a highly elastic, three-dimensional web.
And that web is entirely responsible for the texture of almost every single baked good we love.
Think about what happens when yeast ferments the sugars in the dough. It releases carbon dioxide gas.
And if there were no gluten, that gas would just bubble up and escape.
Right, leaving you with a flat, dense cracker. But the gluten network acts like millions of microscopic balloons, trapping that gas.
It expands, it stretches without tearing, and it gives bread its airy, chewy, soft crumb.
It's a miracle of food chemistry, honestly.
It is. But here's where my curiosity starts to shift into skepticism.
How so?
Well, if gluten is just a natural plant protein that makes bread fluffy, Why are we suddenly seeing this massive explosion of sensitivities, leaky guts, and autoimmune cross-reactions?
That is the million-dollar question.
Right, like has human biology suddenly become fragile in the last 20 years?
To answer that, you have to look at the intersection of human agriculture and immunology. We didn't just wake up one day with weaker stomachs.
The wheat we are eating today is fundamentally not the wheat our ancestors ate even 100 years ago, is it?
Not at all. We have to talk about the agricultural hybridization in the mid-20th century.
You're talking about the Green Revolution.
Exactly. Agronomists like Norman Borlaug did incredible Nobel Prize-winning work to crossbreed wheat varieties. They created dwarf wheat.
They made it shorter so it wouldn't blow over in the wind, right?
Yes, and they made it incredibly high yield and highly resistant to disease. It literally saved millions of people from starvation globally.
But in the process of rapidly hybridizing these plants, we fundamentally altered the protein profile of the grain.
We accidentally reinforced the rebar.
Man, that is such a crazy way to think about it.
Modern commercial wheat has been bred to contain a much higher ratio of gluten, specifically the gliadin fraction of the protein.
Because it makes for better, softer, more shelf-stable commercial baked goods.
Right. So we drastically increased our exposure to a very specific, structurally complex protein in a microscopic evolutionary time frame.
And because it's such a brilliant, cheap structural binder, the food industry didn't just leave it in bread.
Oh, not even close. It's ubiquitous.
When you dive into the research of where gluten hides, it is staggering. Obviously, it's in cakes, tortillas, and donuts.
But it's also used as a thickener in commercial soups.
And it's a binder in processed deli meats. I mean, that turkey you're eating might literally be glued together with wheat protein.
Spice mixes use it to prevent clumping. It's even deeply embedded in fermentation processes.
Like soy sauce, right?
Exactly. Most commercial soy sauce is brewed using roasted wheat alongside the soybeans. The wheat provides the starches and proteins that the fermentation cultures feed on.
So a patient might be desperately trying to identify what is causing their joint pain. They eat a simple piece of grilled chicken marinated in soy sauce,
And they wake up in absolute agony.
completely unaware that they just consumed a highly concentrated dose of the exact protein they are trying to avoid.
Which brings up a really insidious trap that I want to unpack, the health halo of the gluten-free aisle.
Oh, yes, the health halo trap.
Okay.
Because if you are a patient in chronic pain and you figure out that this wheat protein is part of the problem, your first instinct is to run to the grocery store.
You go and buy everything with a giant green gluten-free label on it.
And that is often where people unknowingly trade one form of inflammation for another.
It's so true. Let's think about the baking analogy again. If you take the structural rebar out of a cookie, you're left with crumbly sand.
So food manufacturers have to replace that elasticity with something.
And what do they use? Highly refined starches. Tapioca starch, potato starch, rice flour.
And to get the moisture and texture right, they often pump these products full of extra saturated fats, chemical binders like xanthan gum, and a massive amount of refined sugar.
So people might switch from a regular cookie to a gluten-free cookie thinking they're making a medical intervention, but they are just swapping gluten for highly processed sugars.
You're removing a problematic protein, yes, but you are replacing it with a glycemic load that hits your bloodstream like a freight train.
Potato starch and tapioca starch have incredibly high glycemic indices. They spike your blood sugar rapidly.
Which in turn causes a massive release of insulin.
And chronic spiked insulin is a massive driver of, you guessed it, systemic inflammation.
So you could have a patient who swaps their whole wheat toast for 2 slices of gluten-free white bread, thinking they're helping their rheumatoid arthritis.
But the resulting blood sugar spike just creates a different chemical pathway to the exact same joint pain.
It's a tragic irony of modern diet culture. The naturally gluten-free foods, rice, quinoa, certified oats, fish, vegetables.
Those are incredibly nutrient dense.
But the highly processed gluten-free substitutes are often just nutritional voids.
Exactly. Okay, so we've established what this protein is, how we've structurally changed it over the last century, and how it is hiding in our food supply.
So let's trace it through the human body, because I really want to understand the actual physics of why this specific protein is so stubborn.
Sure, let's trace it.
Let's say I take a bite of a regular gluten-filled baguette. Walk me through the mechanics. What happens first?
Well, the mechanical digestion starts in your mouth. You chew, increasing the surface area, and your salivary glands immediately release enzymes.
Primarily amylase, right, which starts breaking down the starches into simple sugars.
Right. But the saliva does absolutely nothing to the gluten-protein network. The chemical bonds holding that rebar together are far too strong.
Okay, so it passes down the esophagus and drops into the stomach. And this is where my intuition always gets tripped up.
How so?
Well, the human stomach is essentially a highly pressurized vat of hydrochloric acid. It has a pH level that can dissolve certain metals.
It does.
And it utilizes an incredibly powerful enzyme called pepsin, whose entire job is to cleave proteins apart.
Correct.
So why doesn't the stomach just melt the gluten down to base amino acids like it does with a piece of steak or a scrambled egg?
What's fascinating here is the deeply complex structural biochemistry of gluten. To understand why pepsin fails, you have to look at what gluten is made of at a molecular level.
Okay, I'm with you.
It is extraordinarily dense in two specific amino acids, glutamine and, more importantly, proline.
Proline. I know amino acids are the building blocks of proteins, but what is so special about proline that it can survive a vat of hydrochloric acid?
Technically, proline is unique among the standard amino acids because it is an amino acid.
An amino acid?
Yeah, without getting bogged down in an organic chemistry lecture, the important thing to visualize is its shape.
Okay.
Most amino acids form long, flexible chains. But proline has a rigid, bulky ring structure built right into its backbone, a pyrrolidine ring.
So instead of a smooth chain, it's like having a giant bulky knot or a sharp kink in the middle of the protein.
Exactly. It creates severe, rigid kinks in the protein folding. Now, remember how enzymes work. They operate on a lock-and-key mechanism.
Right.
An enzyme like pepsin has a very specifically shaped active site, the keyhole. It floats around, finds a protein chain that fits perfectly into that keyhole, and snips the bond.
Ah, I see where this is going. And because gluten is absolutely packed with these bulky proline rings,
It doesn't fit in the keyhole.
physically cannot fit.
The bulky ring creates what chemists call steric hindrance. It literally blocks the human digestive enzymes from accessing the chemical bonds they need to cut. Our evolutionary hardware, our specific set of proteases and peptidases, simply never evolved the specific keys required to unlock and dismantle this particular proline-rich structure.
That is wild. It's like swallowing a Lego block. Your stomach acid tries to melt it, the pepsin tries to pull the individual studs apart, but they just can't get a grip on it.
That's a perfect analogy.
So instead of breaking it down into individual single plastic Lego bricks, which would be single amino acids that your body can absorb and use for building muscle, it just breaks off into jagged chunks.
Yes, chunks of maybe 10, 20, or 30 amino acids still chemically bonded together. In biology, we call these unbroken chains peptides.
And this is the part that I think most people fundamentally misunderstand.
What's that?
I always assumed that people with celiac disease or gluten sensitivity couldn't digest gluten, but normal, healthy people digested it just fine.
Oh, right.
But the biochemical reality is that nobody digests it.
Exactly. No human being on Earth completely digests gluten. We all lack the enzymes to break down those specific proline and glutamine bonds.
That is so counterintuitive.
Every single person who eats a piece of bread produces those exact same jagged, undigested peptide chunks in their stomach.
Which again points to that evolutionary mismatch we talked about. We adopted agriculture and wheat farming roughly 10,000 years ago.
Which is nothing on an evolutionary scale.
Right. In the grand timeline of human evolution, where our digestive tracts were adapting over hundreds of thousands of years, 10,000 years is basically yesterday.
We introduced this complex, rigid protein into our daily diet at a massive scale, and our biology just hasn't had the time to write the genetic code for the enzyme required to digest it cleanly.
It is a profound evolutionary lag.
Yeah.
We're eating a modern, hyperabundant diet with ancient hunter-gatherer digestive hardware.
Okay, so every human is producing these stubborn, undigested gluten peptides. For someone with a perfectly resilient system, what happens to those Lego chunks once they leave the stomach and enter the small intestine?
Yeah, where do they go?
In a highly robust, healthy individual, those large peptides travel into the small intestine. They might be fermented a bit by the gut microbiome, but mostly they just bounce off the lining of the intestine.
And are eventually excreted as waste.
Exactly. They remain in the digestive tube, which is technically the outside of your internal body, and they pass through harmlessly.
But for a massive portion of the population, those peptides do not just bounce off harmlessly.
No, they don't.
They initiate a cascade of events that breaks down the very barrier protecting our bloodstream. Let's move down into the small intestine, because this is where the plot really thickens.
We have to talk about zonulin.
Yes, zonulin. The discovery of zonulin by Dr. Alessio Fasano and his team in the early 2000s completely revolutionized our understanding of all this.
It really was the missing mechanical link in understanding intestinal permeability, autoimmune disease, and food sensitivities.
Let's set the stage first. The small intestine is lined with a single layer of epithelial cells called enterocytes.
And their job is incredibly difficult. They have to act as a highly selective filter.
They need to absorb tiny, fully digested nutrients, right? Like water, individual vitamins, single amino acids, and let them into the bloodstream.
But they simultaneously have to block everything else. Bacteria, toxins, and large undigested proteins like our gluten peptides.
To manage this, these epithelial cells are glued together by complex protein structures called tight junctions.
If you imagine the cells as a row of bricks, the tight junctions are the highly specialized mortar between them.
But unlike brick mortar, tight junctions are dynamic. They can open and close.
Here's where it gets really interesting. How do you visualize the gut lining?
I always picture the gut lining as the wall of an exclusive nightclub, and the tight junctions are the bouncers.
Okay, I like that.
They stand at the doors checking IDs. If you are a single vitamin C molecule, the bouncer says, go right in. The bloodstream is waiting.
But if you are a massive, rowdy, 30 amino acid long gluten peptide?
The bouncer is supposed to say, absolutely not. You aren't on the list. Stay in the digestive tract and head for the exit.
That is exactly how it should work. But in susceptible individuals, when those specific gluten peptides come into physical contact with receptors on the surface of those intestinal cells, something else happens.
Specifically one known as the 33-mer peptide, right? Which is incredibly resistant to digestion.
Right. When it touches the receptors, it triggers the cell to manufacture and secrete the protein zonulin.
And what does the zonulin do to our bouncers?
Zonulin binds to a different set of receptors on the cells, and it acts as an override signal. It chemically forces the proteins that make up the tight junctions to detach from one another.
It pulls the cells apart.
It's like someone slipping a $100 bill to the bouncer and saying, "Prop, the VIP door is wide open."
And suddenly, the physical barrier is compromised. You have created a state of increased intestinal permeability.
The colloquial term, which is highly descriptive, is leaky gut.
The doors are open. So now those large, jagged gluten peptides, along with other opportunistic bacteria and environmental toxins that were supposed to be kept safely inside the digestive tube, can just slip right between the cells.
They flood into the bloodstream.
And waiting for them on the other side of that single-cell barrier is the most concentrated military force in the human body.
The statistic from the text that always floors me is that approximately 70% of the entire human immune system is stationed right there, connected to the gut.
70%. That's massive.
It's called the gut-associated lymphoid tissue, or GLTL. And when you think about it biologically, it makes perfect sense.
That's so.
The digestive tract is a continuous hollow tube open at both ends. The food you eat is foreign matter from the external environment.
Right.
Your gut is the largest surface area of your body. It's about the size of a tennis court if you flatten it out. It's the largest area that interacts with the outside world.
So if you are a biological organism, you're going to station 70% of your defense army right at that massive border.
Exactly. Ready to neutralize anything that breaches the wall.
So the tight junctions open, the gluten peptides slip through, and the guilt army sees them.
It sees this weird, kinky, proline-rich protein structure floating in the blood where it has absolutely no business being.
The immune system immediately flags it as a foreign invader, like a virus or a parasite, and launches an attack.
But here is where we have to be very precise, because the research delineates two very different types of immune wars that can break out here.
There is celiac disease, and there is non-celiac gluten sensitivity.
Let's start with celiac, because that is a highly specific, destructive autoimmune loop.
Celiac disease is fascinating and, frankly, devastating because it involves an incredible biochemical error.
When the gluten peptide crosses the barrier, it encounters an enzyme in the tissue called tissue transglutaminase, or TTG.
And this enzyme actually alters the gluten peptide, doesn't it?
Yes, it performs a process called deamidation, stripping away an ammonia group from the glutamine amino acids.
It essentially modifies the shape and the electrical charge of the peptide.
It makes the peptide highly negatively charged. And this modified charged gluten peptide happens to fit absolutely perfectly into specific receptors on the surface of the immune system's T cells.
It's like the key certainly fits the ignition of a tank.
Exactly. When that modified peptide binds to the T cell, it activates a massive, aggressive, adaptive immune response. The T cells start releasing inflammatory cytokines.
And they signal B cells to produce antibodies.
But the tragedy of celiac disease is that the immune system doesn't just attack the gluten.
In its fury, it mistakenly identifies that TTG enzyme as part of the enemy.
And that enzyme is a natural part of your own intestinal tissue, so it launches a full-scale autoimmune attack on the lining of the small intestine itself.
And the specific targets of that collateral damage are the villi. I want to spend a second on the villi because their destruction is catastrophic.
Go for it. How do you describe the villi?
If the lining of the intestine is a tennis court, it's not a smooth clay court. It's covered in millions of tiny, microscopic, hair-like projections.
Imagine a thick, plush 1970s shag carpet. Those fibers are the villi.
Their purpose is to exponentially increase the surface area of the gut, allowing maximum absorption of vitamins, minerals, fats, and carbohydrates from your food.
But in celiac disease, that activated T-cell army acts like a lawnmower. The inflammation destroys and flattens those villi.
The shag carpet is mowed down to a smooth, hard floor.
It is called villus atrophy, and the clinical consequences are severe. This isn't just about getting a stomachache after eating pasta.
If you have no villi, you have drastically reduced your physical capacity to absorb nutrition.
You can be eating 3 massive, calorically dense meals a day and still be slowly starving to death on a cellular level.
That is terrifying.
Patients develop severe anemia because they can't absorb iron. They develop osteoporosis early in life because they can't absorb calcium or vitamin D.
They experience chronic, crushing fatigue, neurological issues, and dangerous unintended weight loss.
It is a profound state of clinical malnutrition driven by autoimmune self-destruction.
Now, what happens if you don't have celiac disease? Let's say a patient with rheumatoid arthritis gets an endoscopy.
The doctor looks at their small intestine and says, "Great news, your villi are perfectly intact. The shag carpet looks beautiful. You test negative for celiac."
But the patient says, "Okay, but every time I eat wheat, my joints swell up and I can't think straight for 2 days."
For decades, the medical establishment told these people it was all in their heads.
Which is one of the great historical failures of modern gastroenterology, honestly.
We now recognize this as non-celiac gluten sensitivity, or NCGS.
So what is physically happening in NCGS if the lawnmower isn't destroying the villi?
In NCGS, the zonulin is still being triggered, the tight junctions are still opening, the leaky gut is still allowing those peptides to cross the barrier.
But instead of triggering that highly specific T-cell and TTG autoimmune loop, the gluten triggers a broader, more generalized response.
Right, a response from the innate immune system.
The innate immune system, the body's first responders.
Cells like macrophages see the peptides, recognize them as foreign, and immediately start pumping out inflammatory cytokines to fight off the perceived invasion.
It creates a state of systemic immune activation and chronic inflammation.
The gut is irritated, yes, which causes the bloating, diarrhea, and abdominal pain. But those inflammatory cytokines don't just stay in the gut.
They travel through the bloodstream.
And that is the exact mechanism that brings us to the core focus of today's deep dive.
The patient with an autoimmune condition like rheumatoid arthritis.
We've established how gluten opens the gates and sounds the inflammatory alarm.
But what happens when those cytokines flood a system that is already stuck in an overactive alarm state?
This is where we have to look at the terrifying synergy of autoimmune overdrive.
In rheumatoid arthritis, the immune system has already lost its tolerance for the self, right?
Yes. It is mistakenly identifying the synovial tissues, the lining of the joints, as an enemy.
It's constantly sending white blood cells to attack the knuckles, the knees, the wrists, causing severe pain, swelling, and eventual joint deformity.
I want to be incredibly precise here, and this is something the research we are looking at highlights emphatically. Gluten does not cause rheumatoid arthritis.
That is such an important point. No one is saying that eating a croissant in 2015 magically programmed your immune system to attack your knees.
RA is incredibly complex. It involves genetic predispositions like the HLA-DRB1 gene, interacting with environmental triggers, viral infections, and potentially shifts in the microbiome.
It is a critical distinction. The spark that started the fire in the joints is multifactorial.
But if a patient with RA also has this gluten sensitivity and leaky gut, eating gluten is like pouring high-octane gasoline onto a fire that is already raging.
because you're constantly flooding the bloodstream with inflammatory cytokines from the gut.
Which just keeps the entire immune army on a hair trigger alert.
But there is another mechanism here, one that I find simultaneously fascinating and terrifying, which explains why this systemic inflammation seems to target specific tissues so aggressively.
You're talking about molecular mimicry.
Yes, molecular mimicry. It is arguably one of the most devious tricks in all of immunology.
To understand how it works, you have to understand how immune cells see the world. They don't have eyes.
A circulating macrophage, or a T cell, operates entirely in the dark, relying on physical touch.
They read the 3D shapes of the proteins they bump into.
They read sequences of amino acids, which are called epitopes, right?
Exactly. It is like highly sophisticated facial recognition software. The immune cell bumps into a molecule, reads the face, the epitope, and checks its database.
If it reads a sequence that belongs to your liver or your heart or your joints, the software says self, friendly, move along.
If it reads a sequence that belongs to a streptococcus bacteria, or in this case, a stubborn, undigested gluten peptide, the software flags it as non-self invader attack.
But the facial recognition software can glitch.
It glitches because nature is highly efficient, and it tends to reuse certain shapes and sequences across wildly different species.
So by pure, tragic biological coincidence, the specific sequence of amino acids on certain fragments of the gluten protein happens to look incredibly similar to the sequence of amino acids found on the surface of human tissues.
And this is cross-reactivity. The immune system generates specific antibodies designed to hunt down and bind that gluten peptide.
But because the face of the gluten peptide looks almost identical to the face of the collagen, or the tissues lining your joints,
Those same antibodies start attacking your joints as collateral damage.
that is molecular mimicry. The immune system isn't being malicious, it's just fiercely confused.
It thinks it is aggressively defending you against a massive invasion of foreign proteins from the digestive tract.
But because the targets look like identical twins at a molecular level, it ends up chewing up your own tissues.
That perfectly explains why a purely digestive event, eating a piece of bread, translates into distant systemic joint pain.
The immune system is prosecuting a war against a food protein, but the battlefield is your knee joint.
And this mechanism is heavily researched across multiple autoimmune conditions, not just RA. We see it in Hashimoto's thyroiditis, where gluten antibodies cross-react with thyroid tissue.
But it is vital to remember that this is highly individual, right? Not every single autoimmune patient experiences this molecular mimicry.
Exactly. For some, their immune software is sharp enough to tell the difference. For others, the cross-reactivity is devastating.
Now, I want to push back on this a bit, or at least introduce the massive confounding variable that makes studying diet and autoimmune disease so frustratingly difficult.
Let's hear it.
When you read the literature, you see thousands of patients reporting that they went on a strict gluten-free diet and their joint pain vanished, their skin cleared up, and their energy returned.
The immediate conclusion is usually, wow, the molecular mimicry stopped. Gluten was the trigger.
But as any good scientist will tell you, correlation does not equal causation, especially in complex dietary interventions.
Right, because what happens when an average person goes on a strict whole food gluten-free diet?
By definition, they have to stop eating fast food burgers, deep-fried chicken nuggets, commercial donuts, and ultra-processed microwave meals.
They are essentially forced to strip the standard Western diet out of their lives.
And that standard Western diet is highly inflammatory on its own, completely independent of gluten.
Exactly. If you stop eating 60 grams of refined sugar and a massive load of inflammatory oxidized seed oils every day, your systemic inflammation is going to plummet.
So the agonizing question for the patient is, did my joint pain vanish because my T cells stopped cross-reacting with the proline glutamine peptides?
Or did my joint pain vanish because I finally stopped bathing my cells in ultra-processed, hyperpalatable junk food?
The honest answer for many patients is likely a combination of both. You remove the specific molecular trigger and you simultaneously lower the overall inflammatory burden on the body.
But you're highlighting the exact reason why tracking this is so maddeningly difficult for the individual.
Which brings us to the psychological and practical reality of the patient experience.
When you read the first-hand accounts, like the detailed logs we've been reviewing from a patient living with RA, the thing that strikes you most isn't the clinical data.
It is the profound vulnerability and the sheer exhaustion of living in a body that feels like it's betraying you.
One of the notes in the source journal reads, "I never thought food could affect my body this deeply until gluten started affecting not only my pain, but even my thoughts and emotions."
That sentence is so powerful because it validates the true systemic reach of this inflammatory cascade.
We spend so much time talking about joints and guts, but we completely forget the brain.
The brain fog, the heaviness. The patient describes days where simply getting out of bed felt incredibly heavy, like gravity had been turned up.
It wasn't just sharp pain in a knuckle, it was a crushing emotional and physical fatigue accompanied by dark, negative thoughts.
And there is hard biological science backing that up, isn't there?
Absolutely. When the gut barrier becomes permeable and the innate immune system starts pumping out those inflammatory cytokines, specifically ones like interleukin-6 and tumor necrosis factor alpha, those molecules don't just stay in the blood.
They can actually cross the blood-brain barrier.
They can.
And what do they do once they get into the brain?
They wreak havoc on neurotransmitter metabolism. High levels of systemic cytokines can literally alter the way your brain produces and utilizes serotonin and dopamine.
They induce what neuroscientists call sickness behavior.
Sickness behavior, like when you have the flu and you just want to curl up in a dark room and not speak to anyone.
Your body is forcing you to conserve energy so the immune system can fight.
Precisely. The brain is interpreting the cytokine flood from the leaky gut as a massive, life-threatening infection.
So it hits the brakes on your mood, your motivation, and your cognitive clarity.
That heaviness and those negative thoughts the patient experienced aren't a psychological weakness. They are a direct neurological symptom of gut-derived systemic inflammation.
Which makes the process of trying to heal so incredibly daunting. Because you are asking a patient who is already exhausted, suffering from brain fog, and in chronic pain to become a meticulous scientist of their own biology.
And the tracking process is brutal because of the delay.
The timeline of food reactions is the single biggest hurdle for patients trying to identify their triggers.
Right, because we are conditioned to expect immediate binary reactions.
If you have an IgE-mediated peanut allergy, you eat a peanut, and within 2 minutes, you are covered in hives and your airway is swelling shut. The cause and effect are undeniable.
But with non-celiac gluten sensitivity and autoimmune cross-reactivity, we're often dealing with IgG or IgA antibodies, or delayed T-cell responses.
Which means the timeline is completely stretched out.
The patient in the logs noted this exact frustration. If you eat a slice of pizza on Monday night, your immune system might start building the antibodies and releasing the cytokines on Tuesday.
And your joints might not actually swell up and scream in pain until Wednesday afternoon.
By Wednesday, the pizza is completely gone from your mind. You're blaming the stress at work or the weather or the salad you had for lunch.
How can a patient possibly establish a reliable cause and effect relationship with a 48-hour delay?
It requires a level of strict, prolonged dietary isolation that most people find incredibly difficult to sustain in the modern world. You cannot just skip gluten for a weekend and declare yourself cured.
The patient we are studying committed to an elimination period of 1 to 1.5 years. Let that sink in.
18 months.
18 months of completely avoiding every crumb of wheat, barley, rye, and all the hidden sources in soy sauces and processed foods, just to establish a clear baseline.
But the long-term data they gathered from that massive commitment is striking.
By removing the trigger for an extended period, they allowed the gut lining time to regenerate.
The enterocytes could replace themselves, the tight junctions could close back up, and the constant flood of zonulin ceased.
And the results were profound. They noted that the joint inflammation reduced significantly, but more importantly, their mind felt clearer.
The emotional heaviness lifted. Their body literally felt lighter.
By sealing the gut, they quieted the systemic alarm bells, and the brain was finally allowed to exit that cytokine-induced sickness behavior.
And what I find most compelling about their account is the nuance they discovered regarding tolerance thresholds.
The immune system is not a static, unchangeable machine. It is a highly dynamic ecosystem.
Yes. They noted that after this long healing period, there were times when they could introduce a previously triggering food, and surprisingly, the body didn't react with a massive flare-up.
That is the beauty of reducing the overall inflammatory burden. If your immune system is already redlining at 99% capacity because of leaky gut, chronic stress, and a poor diet,
then one single gluten peptide can push it over the edge to 100% and cause a massive RA flare.
But if you spend a year healing the gut, sleeping well, and eating nutrient-dense foods, your baseline inflammation might drop down to 20%.
So if you accidentally consume a little bit of cross-contaminated soy sauce, your immune system might bump up to 25%. It notices the invader, it handles it, but it has the bandwidth to process it without triggering a catastrophic, full-body autoimmune meltdown.
You have widened your biological margin of error. But the patient also wisely notes that gluten is just one piece of a massive dietary puzzle.
They specifically point out they also had to monitor lectins, highly refined carbohydrates, and simple sugars. It's a holistic web, not a single magic bullet.
So as we pull all of these threads together, what is the ultimate takeaway for someone wading through these muddy diagnostic waters?
Well, we started with a sticky elastic protein, the culinary rebar holding our bread together.
A protein filled with rigid proline rings that our evolutionary hardware fundamentally cannot dismantle, leaving us with stubborn peptide chunks.
In sensitive individuals, those chunks bribe the bouncers. They trigger zonulin, open the tight junctions, and cause a leaky gut, allowing the peptides to flood into the bloodstream where 70% of the immune system is waiting.
The immune system attacks. And through the tragic glitch of molecular mimicry, it might mistake the amino acid sequence of the gluten for the tissues of your own joints, pouring gasoline on conditions like rheumatoid arthritis.
And the fallout isn't just physical pain, it's the cytokines crossing into the brain, causing the heavy, crushing fatigue and brain fog that robs patients of their vitality.
And fixing it requires immense patience, meticulous tracking, and the understanding that your body's reactions are delayed and highly individualized.
The most important paradigm shift here is moving away from the fear-based diet culture mindset. It is not about labeling a protein as evil.
It is about cultivating a mature, quiet, and honest dialogue with your own unique biology.
It's about becoming a deeply observant student of how your specific immune system responds to the environment you put it in.
But I want to leave you with a final thought to chew on, something that really expands the scope of everything we've talked about today.
We have spent an hour detailing how the immune system can mistake a food protein for human tissue and how our enzymes fail against these specific molecular bonds.
But if you zoom out and look at the history of human agriculture and food processing,
we have fundamentally engineered the food supply in a fraction of a biological second. We hybridized the wheat to increase the gluten, we isolated the proteins to use as cheap binders in deli meats, and we created hyper-palatable, ultra-processed food matrices that our ancestors couldn't have even imagined.
we took a protein that was already hard to digest, amplified it, and put it in absolutely everything.
Exactly. So the profound question isn't just, why is my body reacting to gluten?
The question is, are our ancient, finely tuned immune systems simply buckling under the weight of an engineered reality they were never designed to recognize?
And if our biology is struggling this profoundly with the structural glue of our modern diet, what other invisible, highly processed daily staples is your immune system silently fighting right now?
That is a staggering thought to end on. A massive thank you for joining us on this deep dive.
It's been a great conversation.
If there is one thing to take away from this journey, it's that the standard medical tests might not always capture the complex reality of food sensitivities and systemic inflammation.
But your own daily observations, your patience, and your willingness to track the delayed patterns are incredibly powerful tools.
Keep asking the hard questions, keep experimenting, and above all, keep listening closely to what your body is trying to tell you.
Thank you so much for watching and spending your time with me. Take care of your body, take care of your mind, and I'll see you in the next video.